Hi, good morning, good afternoon, good evening. And I'll just, before starting off, I'll just give a quick intro to myself. I am at a company called Nutanix. We do hyper-converged multi-cloud platform. But essentially what I do over there is to manage P&L engineering for AI-driven ops. And also I do incubations in the open source space. And we're trying to figure out how do we build the best quality infrastructure, mostly open source, for AI as a workload. And I've been a founding member at MLCommons, done open source for a while now, ML Kubeflow, OpenStack, and even some Apache stuff. And I've collaborated with many of the attendees and speakers over here. So it's really exciting to be back here to talk about open infrastructure. And let's, so in this talk, because most people over here are being infra-centric, I'm just going to switch I'm going to just switch gears and make it more workload-centric and talk about why. I mean, I know Nick from Meta had a beautiful talk in the morning, but I think I want to give a slightly different color and talk about a few different problems that the enterprise faces, the traditional enterprise rather than the hyperscalers. So as we know that AI is fueling the digital transformation of companies. And you have, and this is like old stuff, right? Data, enterprise has data, there's explosion, people are doing AI. I mean, and this is not just early experimental workloads. There are different surveys that says at least 1/3 of enterprises are actually doing some AI as their workload. And once you do AI, you get some insights, you take some actions, life is good. And with that, you can do digital transformation, whether it's figuring out better manufacturing pipelines, or you want to do better medical transcription, you want to understand whether there's PII data being shared in your enterprises for security. There's just tons of stuff that happen. And AI can basically accelerate just by giving you insight that you cannot just get done by rule-based. Because if it's simple stuff, you can do rule-based and get away. So the key challenge is that how do I accelerate my business as a customer with MLOps? And I'll talk about what MLOps is. And MLOps, let's assume that MLOps for now is basically operations, all the operational stuff you need to put ML into practice. And what we've noticed is, if you look at, so most people, when you talk about ML, they'll come to you and say, well, it's very use case specific. What's your use case? But when you look at all these use cases across finance, retail, pharma, healthcare, public sector, and you look at what kind of data they're accessing and what kind of workloads they're doing, you'll see that the enterprise use cases will all use very similar hardware primitives. And that's what MLOps is. MLOps is workflows and best practices for actually putting ML into practice, starting with your data, how you label the data, how you train your models. Let's assume model is a black box for now, for this talk. It's a mathematical model that looks at the data and tunes itself with certain algorithms. Let's oversimplify it. And then once you have a model, which is like a blob or a container, how do you deploy that model? And then how do you take feedback and you take feedback from this deployed model, look at drift and things like that, and you improve and iterate and build better models. But and this is, if you look at this whole life cycle and you look at enterprise workloads, and this is a recent survey from last year, most enterprises, if you look at any enterprise, you'll find a blob that depicts your workload. And with that, for each of those blobs, you'll find that there is either a deep learning or a traditional learning model that you need to productionize. And that is the real deal about MLOps. And if you think about it, ML needs data. So where is your valuable enterprise data? So the data can be in your, all the way from far edge to your data center. So which means that all the MLOps that you do has to be consistent, has to kind of be on an enterprise-grade platform. You can't just build a bespoke platform and let a traditional enterprise use it. It's much harder. So these are some of the requirements, and the real, I feel, the OPI opportunity is treat MLOps as a first-class workload for all the innovations that you do, because the traditional enterprise, as they're morphing from into the software 2.0 kind of an enterprise, they're going to use machine learning as a first-class citizen. Today, applications like databases are first-class citizens, but the first-class citizens of tomorrow will include machine learning. And when you look at machine learning, don't look at just models, but also look at all the entire lifecycle together, and look at how do you do data labeling. So if you're at the far edge on a camera and you're getting data from a camera, look at data labeling problems, streaming machine learning inference. So I know that it's on the OPI roadmap, the inline acceleration. So there's a lot of, so when you look from ML lifecycle applications from the far edge to the core, you're going to see a whole lot of opportunities. And one of the trends that we've seen, I mean, I've been fortunate enough to kind of deal with MLOps and try to solve this problem for last 3 years, perhaps. And we've noticed that most proprietary solutions don't have that amount of uptake. In the enterprise are really warming up to open source MLOps tools and ML frameworks. And look at and for those who are just curious, just look at our Argo as a general workflow engine, Kubeflow on top of Kubernetes, and MLflow from Databricks. I think these three would be good points to triangulate in MLOps. Now, it's a huge market opportunity. I'm not going to spend much time on this, and it's a huge ecosystem, a lot of startups, but I personally believe that open source is going to be a leveler. And that's why I'm so excited to be here. And if you think about what are the interesting technical problems. So I think the technical problem is if you treat ML machine learning as a first-class citizen, if we can optimize and benchmark the entire MLOps lifecycle, but in particular, large-scale training to begin with, and high throughput, low latency inference at the edge. So let's see what's going on today. And actually, Nick from Meta talked a lot about this. If you think about what's going on today, let's look at the top. Blob over here. So essentially, a machine learning workload can be written in terms of, let's assume you're using deep learning. So it's a neural network, and you have a neural network graph structure. So essentially, you have a huge graph that you want to infer. So from a systems point of view, suppose you had a big graph and you had flows and parameters that you didn't know, and you have to discover based on the data that you see. That is the process of training. So let's oversimplify it. I'm just trying to grossly oversimplify. So let's say your machine learning model is a graph G that you want to train based on data, and the graph is big enough. So what you would do is you would do distributed training. And in order to do that, you would partition the graph or do all kinds of strategies, or use a parameter server to kind of do barrier style calculations. Essentially, you're doing if you're from a very traditional computer science perspective, you're doing domain decomposition, partitioning of graphs, doing a lot of graph walks with matrix multiplies, and generating a lot of communication complexity. And the funny thing is that you're training over lots of data. So the data is often in some kind of a storage device. And people are building all these compute device accelerated with the best CPUs and everything, right? Heterogeneous, traditionally in a customer, multi-vendor deployment, you'll have heterogeneous accelerators. And guess what? most of the time is spent shuffling data across the compute clusters and the storage clusters. And this leads to a huge amount of power usage, a lot of inefficiencies. And our good old network becomes the bottleneck over and over again, because now you're doing iterative training, because this graph needs to be trained in multiple epochs or iterations. So you're going to do a lot of back and forth. And that's another reason I asked Nick the question, that as enterprises are beginning to train very large models like the hyperscalers, because they're looking at NLP, they're looking at recommendation systems like the Targets and the Walmarts of the world. And NLP is going to be used almost in every enterprise. And these models are big. So all this while we were looking at the model data, the data for training the models being in petabytes. Very soon, I believe that you're going to see the graph or the parameters or the model parameters hit a petabyte. And it's not there yet, but I think it's getting close. Especially when I talk to my friends in academia, it's getting pretty close. And then it will become extremely expensive just to train even a single epoch. And the bottleneck will be I/O. And today, the bottleneck is mostly, people talk about GPU-based accelerations, all kinds of heterogeneous accelerators, but I believe that I/O is going to be the biggest bottleneck going forward. And in order to do this, I believe that actually within open source communities, like in this particular community, when we look at what interfaces to build and what drivers to support, what frameworks to support, I think one of the things would be, if you all agree that AI ML is a first-class citizen, not something that you do towards the end, like only after everything has been done. If you take, and we'll talk about what kind of workloads you can look at. Let's have the community build reference architectures that would have distributed training as a starting workload, and use either TensorFlow or PyTorch or MXNet, don't care what, but everything, let's build everything on top of Kubernetes, because containerization is already there for most machine learning frameworks. So let's start with containers, let's build the right interfaces, let's do performance tuning from day zero. And I think we'll be good towards the end of at the end of the day. And within our team, we are investing in a couple of open source projects. So we'll talk. We're not going to talk about them, but we've been very early investors in Kubeflow for MLOps workflows. We are happy to collaborate on ensuring the Kubeflow pipelines, which is basically an entire workflow DAG, can be deployed and also accelerated on OPI. And the other thing that we are investing in is we are early members of MLCommons, which a lot of you are also members of, and we want to work. I would ask or request the community to kind of work with a benchmarking community like MLCommons and look at MLPerf as a reference workload. And you can take a look at, you can start with 2 or 3 reference workloads, because it's a collection of, so MLCommons basically defines a collection of workflows, workloads, and people develop benchmarks for it. I would just start with a few, create a reference architecture for these workloads, and then look at it. So another thing is, think about how do you build best practices in this area. So the biggest challenge in the enterprise is you can build a lot of cool infrastructure stack. How do you do a push button deployment at any enterprise? Can we do that in open source? Can we do that? Can we build an ML stack, push button ML stack with IPDK interfaces activated for a class of targets, and basically ensure that we can have shareable infrastructure, because most enterprises don't want to build bespoke infrastructure unless you're Facebook scale. So for shareable infrastructure, how do you how do you run these workloads? What are the best practices? And MLCommons has a bunch of a small subtrack where they're looking at ML cubes as the way to kind of do push button deployment. Can we work with that community and enable acceleration? And there's a new subgroup called ML Perf Storage. Basically, we are trying to define the storage ML benchmarks. And Jonu, who's also attending this conference from Nutanix, he's a co-chair of that. So please feel free to reach out to him. There are a lot of folks from the storage and as well as infrastructure community already there. And we're trying to figure out what are the reference architectures and benchmarks for building realistic benchmarks where the storage is also a bottleneck. All this while, if you look at machine learning benchmarks, storage has not been the bottleneck. But now that things are changing, how do we build better benchmarks? So that's the short pitch I had, but I wanted to kind of end this talk with a couple of researchy futures. I mean, when I look at disaggregated storage and compute, I mean, I feel that if you look at the ML community and the infrastructure community, they're replicating a lot of the tricks that we've, like the ML community is. So if you think about the traditional ML community, they are not infrastructure people, and vice versa, of course. And there are not that many people who understand both. So what happens is the ML community is replicating a lot of infrastructure tricks in the ML layers. Look at, for example, in TensorFlow, look at TF data interfaces. So can we work together to think about how do we fundamentally build brand new infrastructure? I mean, Nick just alluded to hardware software co-design in his keynote, but I would like to double click and say that can we do like ML primitives, ML training primitives that you can then accelerate with infrastructure primitives and then pass hints back and forth. So for example, in distributed learning, can you push down your ML primitives all the way deep into the infrastructure rather than having it in a compute only cluster? That's like, people have done this in databases. They've done this in other fields, push down predicates. Can we do push down ML predicates? And that's an open question. And we are trying to work, and this will not be solved by one entity, but it'll need a community to do that. So we are working with a bunch of academics, would love to collaborate with anybody over here. And that's just distributed training. And then there are these new mechanisms for learning that we think is very important as privacy and security of data become more important. So we want to look at split learning, federated learning. And one of the things that really excited me when Kyle came and talked about this with me is that, like, can we use SPDK primitives for storage and ML combo? Like, how do we do push down predicates? So I think we're like at a tip of the iceberg because this community is just beginning to rev up, and there's going to be a lot of work. And I haven't even gone into the day two problems like infrastructure optimization and scheduling. That will need a whole different session. So I just wanted to give a short talk and have more questions and kind of, and by the way, as part of the background, I've looked at both ML as well as infrastructure quite a bit. So I'm happy to be, I'm happy to help in any way, like being a glue. And John, who's also there, he's heavily into open source. So this part of our company is completely open source, the AI infra stuff. So we're happy to participate and collaborate and benchmark and move the needle because I feel that when you benchmark and you create best practices, that's when you really move the needle in the enterprise. And with that, I'm happy to answer questions.
Thank you. So do remind everyone, please type in your questions down below. In the meantime, I'm going to ask you a question that we've asked a couple of our speakers so far to get things started. How large, you mentioned open source. So how large of an impact is it for vendors that fail on you, that if vendors fail to upstream their drivers or upstream in a timely manner?
So I think upstreaming, look, I'm going to talk not as a vendor, but just as an application, a data scientist trying to use better infrastructure, right? Whenever a new accelerator is in the market or a new reference design is in the market, it's important to have not just the driver, but an entire push button way to get there, right? So I think when you work backwards, I would say driver upstreaming is critical. It's like day -1, because otherwise because there's a lot of stuff. Most vendor teams only think about the driver as the final deliverable, but as an application consumer, I'm looking at it like at least Kubernetes support. And I would look towards a Kubernetes vendor, be it Red Hat, be it Rancher, Canonical, or Nutanix, or anybody, right? Like I want support at the Kubernetes layer.
Thanks. Question then. What is the biggest thing the infrastructure layer could provide to make machine learning easier for enterprises to consume?
Push button deployments and automation. I think most enterprise consumers of AI/ML that I've talked to, the biggest challenge is how do I get started with this, with a hello world? Just a simple, show me how you differentiate between a cat and a dog with a deep learning workload, and just run it for me on my Kubernetes infra or whatever. Most people are moving towards Kubernetes, at least the AI/ML folks. So I would say that would be my hello world. And I see Rob also asked me another question. What is the hello world of ML predicates? That's a very interesting question. So it depends on whether you want to do training or inference. On the inference side, it's easy. You would do a lot of pre-processing and feature extraction and normalization just for images, for example. So you would push down a lot of those predicates into your infrastructure as you look at data, as you stream data into the infrastructure. And for training, I think there are many ways to look at it. It depends on the workload. It's very workload dependent, and we're still trying to crack that for certain workloads. But if you look at some of the, so if you think about the graph, like training graph, and you decompose the graph, and if you assume that the data needed to train the data needed to train that part of the graph is somewhat local, you could then basically take some layers and just have the training for those layers as predicates and push it down into the storage. So it is not just the primitives, you also need to ensure that the data layout is optimized.
Okay, great. We have time for a few more.
Yeah.
The AI pipeline can be built out of smart cameras, processor accelerators, AI on the disk, your computational storage. Do you think OPI can be used by AI frameworks to actually discover what resources can be used?
So I think if you look at AI frameworks, that's a very big topic. So let's assume that there is the basic AI, like let's assume the basic TensorFlow, PyTorch, these are just workloads, right? These are just frameworks that help you express the graph and then compile it and run it. So that part, I think it'll be hard. You have to interface at the layer on top of it. And that's why I use the term MLOps meet OPI rather than AI infra meet OPI. So within your MLOps ecosystem, you could have a discovery layer that talks to the infrastructure layer and does discovery, whether it plugs into the service mesh or has operators. Like how you do it, we can talk about it, but I think you need to do discovery of accelerators and what hints you can pass on. So that's actually one of those things that we can work together. Like what kind of hints can the MLOps layer or learn from the infrastructure? And so there'll be a discovery there and all that stuff, usual system stuff.
Okay, great. We have one last question. What is the abstraction that a user would want to see?
Yeah, that's a great question. So as a user, I would like to just get hints from the infrastructure as to what capabilities I have. And I would like to pass that on to my machine learning framework / scheduler / compilers and all that to optimize it. Because as a user, I just want cost efficient, high performance, low latency infrastructure. So the best I can hope is, the simplest thing I can hope is hints. And if you can give me an SDK or an API where I can learn about, I can discover acceleration primitives and pass on hints, I'm good.
Question then, hints as in classification hints or scheduling hints or something more?
So I will start with scheduling hints is absolutely important, because if I can't do data partitioning and scheduling, I'm not going to get the benefits of the infrastructure. And classification, I'll probably have to double click as to what classification hints mean. But when you discover accelerators, you would like to classify them into different types, whether it can do inline, whether it can do a push down predicate acceleration. I would love to know more about what it is, but in general, yes to both.
Great. Thank you, Debo. This was very, very interesting. If anybody has questions specifically for him, feel free to use chat, either go to everyone or privately